Okay, we've seen how delegation creates a dependency between a container object and the object that it contains. This happens internally within a method and is the weakest form of composition. It is weak because, as it is internal within a method, it is completely encapsulated within the method. Therefore, the relationship between the container and the contained object is loose. The contained object can be changed at any point. At another level, again, at a method level, parameters that are passed in to a method and a parameter that is returned from a method are also forms of composition, except at this level they are known as associations. Now, unlike a basic dependency that we would have as a delegate, using an association forms part of the whole class signature, if you like, of an object. That is to say, we are not free to change public methods, the signature of public methods. Therefore, the return types and the method parameters are effectively a contractual part of the class itself. Okay, when most people talk about composition, however, they're talking of things that happen at a class level, not a method level. And we have effectively got two different types of composition that apply at a class level. We have aggregation, which is loose, and we've got full-blown composition, which is a far, far closer and stronger relationship. So an object and this is looking at composition at a top level here. An object can be built or created by including information about the object as variables that are declared as part of the class definition. We call these instance variables, and these can be objects or primitive types. Now, we do not ordinarily refer to primitive types as a form of composition, and we certainly don't illustrate them on UML diagrams, unless, of course, it is an array of primitive types. But as you already know, an array of primitive types is not a primitive type itself. It is in fact an object. An example would be a car. A car class might have an engine, which has itself got an engine size. A car has a driver. A car has 4 tires. A car has a model name. A car has an ability to calculate how long it is before we have to take it in to get a mechanic to service it. You notice that we're using the word has quite a lot, and this is the rule of thumb that we apply to denote whether or not the relationship between two objects is one of composition. It is known as the has-a rule. We might say, for example, a student has an ID, a student has a course, a student has a set of books, a student has a study routine. So this denotes that really the form of reuse we're talking about here ought to be one of using composition, one of the 4 forms. So a composition relationship allows an object to be created from things like primitive types. In the case of a car, a float for the size of the engine, a 1.4, 1.6 or 2-litre engine. Okay, another object, driver, or even a set of drivers. Okay, collections of objects or primitives, an array or set or list of tires, and then a suite of methods. Okay, the expected time to service, car.drive, car.stop, car.handbrake turn, or something like that. At some point during the life of an object, the values are set. We know that the values of instance variables are set after the constructor is fired and the object is placed on a heap. The mechanism is called composition because the object is composed of these objects and primitives. So composition is used anytime, and this is a rule of thumb, the has-a relationship exists. And we should second guess ourselves every time we're stating this. Okay, we should ask ourselves the question, object A has an object B. Is that true? And if it's not true, or it's not always true, we should think long and hard about what we're doing. Maybe composition is wrong and is the wrong form of reuse we're talking about here. 80% of the time it is not wrong. It is the correct form of reuse. We'll see that is a rule for inheritance used incorrectly is the one that could cause the problems. So to build an object using composition, an instance variable is created to represent the property needed. And the composition is not just used for properties of data values, it can also be used for calculated attributes, but generally speaking this would be a no-no. We typically don't want to store calculated information anywhere, even temporarily, unless it's a matter of performance in a high performance environment that we might want to calculate this at a certain point, because calculating it dynamically each time on the fly might be prohibitively expensive for some reason. So we can do this, but typically it's getter-setter methods. Composition is used in two ways, and now there's another rule of thumb you really ought to know here, that composition goes hand in hand with delegation. Okay, delegation is a form of composition. We are composing ourselves with an object in order to reuse it. Therefore, we should be delegating behavior in order to get that reuse. So our mantra really here should be to compose and delegate, compose and delegate. So composition can be used in two ways at a class level to create an object. In a full-blown composition, the classes that we're reusing are completely encapsulated inside a container object. This is full composition, and we have a special notation in UML for this. The weaker form of it is it's still at a class level, they're still defined as instance variables, they're defined in exactly the same way. The object might have an existence outside of the container object, and we call this aggregation. Now, unfortunately, a lot of the literature and books, okay, swap and use these terms interchangeably, and it's not quite clear what is what. They're used as synonyms, and this can cause a lot of confusion. Some people call this association and aggregation, so we've authors themselves disagreeing. However, I believe that the best way to distinguish between them is using their life cycle, and this is what the UML notation forces us to do. It's quite clear, it's unambiguous what's happening, and we will see that's the life cycle, okay, and the actual degree of encapsulation of an object, i.e. how visible it is, how it can form a dependency, that these are the things that determine the type of composition that we're talking about. So in any form of composition, objects make up an interdependent whole. In other words, just like our own bodies are composed of different organs, okay, that we have an object is basically composed of other objects. The contained objects exist and relate only to the container of an object in full composition. What this means is that if you are completely contained within another object, you are completely encapsulated inside that other object. If you're completely encapsulated inside that other object, no other object from the outside can see you. Okay? If that is the case, then your life cycles are intertwined. In other words, if the container is destroyed, then the contained object is destroyed with it. So composition, in this case, indicates that one class actually belongs to the other. That doesn't mean it can never have an existence outside each other. It means that when it's used in this context, when the container dies, the contained object is going to be destroyed with it. For example, a polygon is made up of several points. We could use points, though, for example, for something like a square or a line or something like this. However, when used in the context of a polygon, if the polygon is destroyed, the set of points that form it, or that it's composed of, are also going to be destroyed with it. That makes sense. Aggregation is a much, much looser form of composition. Both of these ideas, don't forget, are created by declaring object variables, and that's done at an instance variable level. But aggregation is a less rigorous way of grouping our things together. To aggregate literally means to bring together. So the object in an aggregation relationship typically contains references to objects that continue to exist regardless of whether the container continues to exist or not. In other words, we're basically passing an object, okay, instances of objects, okay, that existed already or could be shared. This is quite normal and is usually what we mean when we talk about a composition relationship. Now, what this means, however, is that in an aggregation relationship, we cannot be sure that if the container dies and is garbage collected, that the contained objects, the objects that it is composed of, that they will be garbage collected with it. That remains to be seen. It may or may not be the case. We cannot give it a guarantee, therefore it is not full composition, it is merely aggregation. We have a special notation for this in UML. If you look at the example here, we have the relationship between three classes, a movie theatre, a box office, and a movie. Now the movie theatre is composed, okay, of one and only one Box office. You will notice, folks, there is a diamond here. The diamond is the UML notation used to denote composition. Now, the box office is part of the movie theatre. If the movie theatre is destroyed, the box office will be destroyed with it. That is what it means. The box office can have no existence outside a movie theatre. Now, you could argue that I need a box office outside of I don't know, a town hall, for example, for a game for bingo or something like this. That is true. However, when used within the context of a movie theatre, that specific instance of a box office belongs to that and only that movie theatre, i.e., that box office should be completely encapsulated inside the movie theatre. I do not see them as separate entities. I see the movie theatre and I pay to see a movie. That is handled internally through a box office, hopefully through the process of delegation. But the box office itself is going to be stored as an instance variable at a top level inside a class called movie theatre. The movie theatre, on the other hand, may be showing many different movies. Now let's pretend that these movies are being streamed from somewhere. And these movies may or may not be showing in other movie theatres. Again, let's imagine it's being streamed out digitally. Okay, now imagine if our movie theatre just disappeared all of a sudden. Well, we know because of the relationship with box office that the box office is going to disappear with the movie theatre. However, the movie itself that was showing, or movies that were shown in the box office theatre, they themselves could be being viewed by people in other movie theatres at the same time. Now, in that case, those instances of the movie class, those movie objects, will survive the destruction of the movie theatre. In other words, their life may, in that case, will, okay, outlive the movie theatre. In other words, the contained can outlive its container, but only because it's being used. Don't forget, folks, in the context of garbage collection, we have the notion of reachability here. If you're in scope, being used from some object that itself is in scope, you cannot be garbage collected. So in other words, aggregation implies that an object, in this case movie, may be shared. It doesn't guarantee it will be shared. If it's not being shared, it will be garbage collected. However, we cannot guarantee that at compile time. That's what it means. So a black diamond implies full composition. A white diamond implies the weaker, looser form of composition that we call aggregation.